Hi guys, Mrs. Tilisin here. Welcome to another lesson of Algebra 2. Today's lesson is all about exponential and log functions. Alright, so we are going to start with something really familiar. We did this one on the second quarter already. So the inverse of a linear function. And we have 4 steps in doing that. So in here, what if now we wish to perform this computation with exponential function? Say for example, we want to find the inverse of f of x equals 2 to the power of x. And we want to find the inverse of this exponential function. We'll start with step number 1, replace f of x with y. So y equals 2 to the power of x. Step number 2, interchange x and y. We have x equals 2 to the power of y. So this is done, that's done. But then if you look at number 3, it's solve for y. I think it is hard to solve for y, right? Because it's in the exponent. Right? If this was like 2y maybe or 2 plus y, then I would be able to solve y doing that by subtracting it or dividing it on both sides. But in this case, it's a power of y. Right? So it is with step 3 that we get stuck. Now, how do we solve for y when it is an exponent? Mathematicians who struggled with this question came up with the idea of using log function to solve for when the exponent is missing. Okay, so we have here a formula that I'm going to highlight. It's technically like not a formula, but like a pattern of some kind. So this will guide us when we want to transform, there you go, transform log functions into exponential or exponential to log functions. So if you notice here, let's see if we can, so the y is y over here. This is, let me name this one. This is the exponential function, and then this is log function. Okay. So let's see where the things go. So the x, so instead of equals x, now the x is inside in here in this parenthesis. And then the base b is now written over here. And then the y is written there. So it's technically, we're just going to use that pattern to rewrite log to exponential, exponential to log. So let's have an example here. So now that we know how a log function looks like, we are now able to continue what we solved earlier and solve number 3. So remember, our step 1 was to replace y, or replace f of x with y. So we have y equals 2 to the power of x. Step 2, interchange the position of x and y. And then now, we are going to rewrite this exponential function into a log function following our, so from here to here. And if you take a look in here, we now have y equals log with a base of 2 of x. And then from there, we are going to replace y with f inverse of x. So we're going to follow the same pattern on trying to find the inverse of this exponential function. So let's start with step 1. I'm going to put step 1 in there. Okay, step 1. We are going to replace f of x with y. So this is y equals 5 to the power of x. Step 2, we are going to interchange x and y. So this is 5 to the power of y. Step 3, we are solving for y using log function. So this is y equals log with a base of 5 in parenthesis x. Okay? So as easy as that, we now have the inverse of the function f of x equals 5 to the power of x. Okay? And then step 4 is we're going to replace y with f inverse of x. And then, of course, it's going to be the same thing. Okay, so in here, our final answer would be log base of 5 of x. Okay, same thing. We are going to step 1, replace f of x with y. Step 2, interchange the position of x and y. And then step 3, we are going to use log functions. So this to solve for the value of y. So that's log base 10 and then x inside. And then we are going to replace that with f inverse of x. So log with the base of 10 of x. So our answer here is, there you go. Not that bad, right? So we just need to know like where the y goes, where the x goes, and where the b that represents base go. Okay, right now I am going to show you what if there is a value for that x. What if the x is not, it's not just a variable x, like say that is a 64 or a 20. Let's put in a number to it. Okay, so let's start with over here. Rewrite each exponential equation in log form, and then you're gonna rewrite each log equation into an exponential form. So you do it backwards, yeah? So let's put the formula somewhere. Let's put it at the bottom. So we have here, I call it formula, but like a pattern of some kind. X is equivalent to, okay, so let's use this pattern in solving for our answers here. Okay, ready? So we have here an exponential function, and we're going to write that into a log. So now the y is the 3, right? So this would be written as 3 equals log with the base of 4 of 64. So technically, this is our y, this is our b, and this is our x. So maybe it's easier to name. Yeah, this is our b, that's our y, that's our x. So when we put them together, that would be 3 over 2 equals log with a base of 9 and 27. All right, there you go. Now we are going to write it from log to an exponential. So this is our base, and this is our x, this is our y. This is our base, this is our x, and that's our y. So let's put them together. So this is 2 to the power of 5 equals x. So equals 32. This is 3 to the power of negative 4 equals 1 over 81. And there you go. Just like that, you've finished how to rewrite exponential equation in log form, or rewrite each log form into exponential form. Okay? I'm hoping that that wasn't super bad. Moving on, we have here, okay, so let me read this quickly. Example number 3. Rewrite 3 to the power of y equals 80 in log form. This is an equation in exponential form with b equals 3 and x is equal to 80. Hence, we can rewrite this as y equals log with the base of 3 of 80. Let's stop and think for a moment. What is the value of y that will make this equation true? Okay, so let's say, you know how you have 3 to the power of y equals 80? So what is the value of y? Like if you're just using, you don't, like say for example, you don't know log functions, right? So you can technically just use like a trial and error kind of thing. So like if I do 3 to the power of 3, this is a trial and error, okay? So if I do 3 to the power of 3, 3 to the power of 3 is only 27, right? So let me put that there. Because we're trying to find the value of y. So 3 to the power of 3 is only 27. But we're looking for 80. So that is too small. If we do 3 to the power of 4, we will get 81. And that is too high, not too high, but that's a little high. So that means whatever this y is, it's not a 3, it's not a 4. So it's a number that is in between 3 and 4. Does that make sense? But then how are you gonna do that? You're gonna type a bunch of there's a bunch of numbers in between 3 and 4, right? So you're gonna just try a bunch of numbers just until you find 80, and that's kind of hard to do. And that's the reason why there is a log function, because log functions would help us solve what that y value is in one click. Okay? Now, some calculators, but not all, okay? Some calculators will allow us to type in a log form, like log with a base of 3 of 80. So usually graphing calculators will allow you to, like, you have like a function where it says log, and then there's a square and then another box, and you're able to put a 3 in there and an 80 in there. But then if your calculators are like, like your phone calculators maybe, or like your computer calculators, they might not have that function. But do not worry about it, because I'm going to teach you how to solve that using any kind of calculators. But for now, we are going to practice how to rewrite exponential into log form. So in here, rewrite each exponential equation in log form, and if you are able to use a calculator to determine the value of y, then do it and leave your answers accurate to 4 decimal places. Okay, so here's the thing. Again, not all calculators will be that you'll be able to solve this one right here. So actually, the y value would be this one, right? So 3.988, that is too much decimals. So let's say if you do 3 to the power of this number, you'll get 80. But then trial and error would take you super long hours to actually find, maybe days to actually know what that number is. Okay, so we're going to use log. So in the next numbers, like in here, in the next examples, you're not really required to solve it. Okay, you're only required to rewrite it. But if you have the calculator that can solve it right now, then please go ahead and do that. So I'm going to start with 2a, which is y equals log. So this is our b and this is our x. So log with a base of 2 and 5. Okay? If you have your calculators, you can really just put this one right away in your calculator, and you will get that y is equal to 2.3219. Again, if you don't have those kind calculator, you can leave your answer like that. Don't worry about it. Moving on, we have y, this is our b, this is our x. And remember, we have y equals b to the power of x, okay? So, b to the power of y, hello. B to the power of y equals x. Okay, just making sure that you didn't forget that. So we have log with a base of 3 of 21. Log base 3 of 21, if you do that in the calculator, you'll get 2.7712. But then again, not required to put that answer, just required to rewrite it. So you have y equals, so this is my b and that's my x. Log with a base of 7, 12.4. If you put that in the calculator, you'll get 2938, I think. Okay? And then here you have y equals log. So this is my b and that's my x. So y equals log with a base of 10 and 31.5. In the calculator, you'll get 4983. Okay, there you have it. The next page would be, which is page 36, is your homework. I hope that you'll be able to do it on your own. If you have any questions, please let me know. And I will see you guys in the next video. Bye.